Okay, welcome back. We're back on Mathia, and we're doing the thing called special right triangles. Now, in the back of the classroom, there's those giant posters that Mr. Miller gave you that's posted. Plus, remember the mailer I sent home. The entire second page is on right triangles and trigonometry. So those special right triangles are at the top. So hopefully that's helpful. Plus, Mr. Miller's got those little props that he's using. This next one is going to be on the 30, 60, 90 degree triangle. Here we go. Okay, my head's always in the way. Alright, so now we got this 30, 60, 90, and there are special properties about the 30, 60, 90. Okay? Now, hopefully you got introduced to this during Pi Day, and we drew a circle and these special triangles, 30 degrees, the 60 degree, okay? And these special lengths, okay? So, if we know one of the lengths, we can calculate all the others. So the key to success, we really like it when they give us the short side. The short side. Now, if we go from the short side, MP, just type in radical 15. So hit this little button, radical 15, enter. Now, PN, from the short side to the long side, okay, not the hypotenuse, this is called the hypotenuse, to the long side, we multiply by radical 3. Now let's see what happens if we multiply 15 times radical 3. Let's see if it gives us the right answer. Awesome! Okay, MN. Now, short side to the hypotenuse, we double it. Double. Okay? Well, we know what that is. 2 times radical 15. Isn't that cool? Alright. So now we're going to complicate it. Tip it on its side here. What do we got? We've got the hypotenuse. That's 2x. So when we bring it back from the hypotenuse, we cut it in half. So let's see, that's GH. So GH down here, let's just type that in. For radical 2. And what? Oh, I don't have it. GK. So GK, cut it in half. So if you're not sure what it is, just type in 4 radical 2. How'd that happen? 4 radical 2 over 2. We're just going to cut it in half. Now, take the short side and multiply by radical 3. So, 2 radical 2. Go outside, multiply radical 3. Dun-dun-dun. It gave us the correct answer on all of them. Okay? So now, what if we have the long leg and we bring it back? Bring it back. We got to divide it out. So 11 radical 3 xz, going to make a fraction, 11 radical 3 over radical 3. We're going to divide it out. Okay? Now we got an 11, go to the hypotenuse, just double. 2 times 11. And z. Oh. We're just typing in the answer. It's given to us. Whoopsie. Okay, now 2 times 11. There we go. Okay. So hopefully that was helpful. Now, what is the length of the shorter leg? The length of the hypotenuse of a pennant. Okay, you ever have one of those pennants, you know? Okay, World's Fair type pennant, baseball pennant. Okay, the short leg. If the hypotenuse is 16, then we divide in half. 16 over 2. Now, the length of the longer leg, okay, length of the longer leg is going to be 8 times radical 3, because you multiply to get there. Now, did we talk about the area of a triangle? Length times width. Remember, length times width. Where's my triangle? There we go. Length of a triangle. Length times width divided by 2. Length times width divided by 2. So we have the length, shorter, longer. So let's get our fraction maker. 8 times 8, radical 3 over 2. Cut it in half. Awesome. All right. Rock and roll is here to stay. Okay, 30, 60, 90. So we're still on the 30, 60, 90. Okay. And remember, this is called the hypotenuse over here, even though one problem they called it the long leg. Okay, radical 3. Now, cable, bridge, eastern cable, straight down, usually both sides. So we got a 30, 60, 90. And we got a 45, 45, 90. Okay. Now cable 1. Cable 1 is right here, 35. So if we take the 35, we'll come down here, divide by radical 3. Okay. So 35. No, cut it in half, right? 35 over 2. Multiply by radical 3. So let's just write that all out. Do we need that? I don't think we need that, do we? So 35, yeah, we're going to cut it in half, right? We cut it in half. So 35 over 2 times radical 3. Cable 1, 35 over 2 is 17 and a half. 17 and a half. Okay, I wonder, radical 3. Cable 1 span. Calculate the length, the span. Cable 1 bridge span. Oh, the short leg. I was overthinking it. In this triangle equal radical 3, you know the length of the leg is 35. Long leg. Bring it back. Ah, Monty. Oh, Monty, Monty, Monty. You know, that's the first mistake I ever made. Okay, the length of cable 1. Length of cable 1 is going to be this doubled. So 20.21 double. Yeah. Okay, cable 2 bridge span. So this one, that's what I was messing up. So now we have 35 and 12. 35 and 12, and it's the same, right? 35 plus 12. Now we're going to have 47, right? Our 45, 45, 90. Where's our 45, 45, 90? 45, 45, 90 multiply by radical 2. Multiply by radical 2. Okay. So it wasn't for being perfect, Monty. Okay, drag and drop. Okay, so now the key. Special right triangles. Got a number, and a radical 2. So look for all the radical 2's. This doesn't have any radicals, so it's nothing. Radical 2, 45, 45, 90. 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 Oh, man. We'll come back to that. So radical 3's. Radical 3's, 5, 10, double. Radical 3, double. Radical 3. Okay. 8, 10, 18. There's no radicals. I'm going to try this. Now, this one. 2 radical 2, double. Isn't it? Why didn't this go 30, 60, 90? Oh, I must have gone to the wrong one. We'll drag and drop. And I think we finished. No. We're going to have one more problem, aren't we? Oh, we finished. Awesome. So the first two workspaces were all about special right triangles. Special right triangles, okay? All right. Let's see what's next before we stop the video. 30, 60, 90, 30, 60, 90, and more calculating. Cool. See you next time.